All right, time for the next example. This one's a little tricky. Notice we have an x in the bottom. And so my question for you is, can you think of something that when we take the derivative of it, we end up with an x in the bottom? So check your notes, maybe pause the video for a second. Can you think of something that when we take the derivative of it, we get x in the bottom? You got it? The answer is a natural log. The derivative of ln of x is 1 over x. Now we've got more than just x down here. We got all of this stuff. And so you'll get instincts of what to let u be over time. For now, I'm just going to tell you, let's get this 8 plus 9x. Let's cram all of that into the u. So u is equal to 8 plus 9x. That means that du dx is equal to just 9 when you take the derivative of that. And so that means that we have du is equal to 9 dx. So again, if you want to, at this point, you can solve it for dx and do a direct substitution. But I'm going to go ahead and just show you what's going to happen here. Notice that on the bottom we get u, because that's what we let u equal, 8 plus 9x. And then notice on the top I have 9 dx, and that's my 9 dx right here. So that 9 dx I can go ahead and just replace with du. And so we've got du over u. And the integral of that is really easy. As I said, it's just the natural log of u. Just like that, plus c. Natural log of u plus c, and we're ready to go ahead and do our final substitution so we can get back in terms of x. And we're done. Because remember, our goal was the u is just a stepping stone so that we can get to the correct answer. Okay? So that's it. You'll notice that it's just a chain rule backwards. You can check your answer. Take the derivative. The c goes away. We get 1 over all of this. And then because of the chain rule, we have to multiply by 9, which gets us right back to where we started. Let's do the last example on this page. I have the integral of ln x to the 8, 1 over x. Again, it's tricky to pick the u. We have 3 sort of options here. I could either let u equal the natural log, I could u equal the natural log to the 8, or I could let u equal 1 over x. And so if it's not working out for you, you probably have the wrong u. Remember, what you're looking for is you're looking for something that if we let u equal it and then take the derivative of it, we get something else in the problem. So can you see if I let u equal something and take the derivative of it, is there anything else we can do? And the answer is yep. On this one, we want to let u equal ln of x. Okay? Because when we take the derivative of it, we get that 1 over x. So let's do that. Du equals 1 over x dx. And we're ready to go. It's really quick most of the time if you do it correctly, if you have the right u. So again, if you're stuck, you probably have the wrong u. So this is going to be u to the 8 because we had ln of x to the 8, and ln was just equal to u. And so now notice, I'm not going to solve for dx. Instead, I'm just going to replace 1 over x dx. I'm going to replace that with du. In order to do the integral, u has to match its variable that we're taking. The variable has to match the variable that we're taking it with respect to. That's going to equal u to the 9 over 9 plus c. Just like that. And then just remember what we let u equal. U was the natural log of x. So the final answer is the natural log of x to the 9th power divided by 9 plus c. And those are a couple examples of u substitution. Don't forget, you can take the derivative to check your answer. But hopefully this is making sense. If not, please let me know. We'll do a couple more examples in the next video.